Hey there, my fellow intellectuals. I know it's been a while since I made a video, so today we're going to be looking at another property of the Dirac Delta Function. Namely, we're going to be looking at what happens if you try and integrate the derivative of the delta function with a function of x underneath an integral sign. So we're supposed to be getting this negative f prime of a as our result. And to remind ourselves about the delta function, remember that if you take the normal delta function, not its derivative, and you integrate it with a function of x, as long as you include the point a in question in the integration bounds, you're going to return the function evaluated at a. So to do this proof, I say proof, mathematicians might not consider it a proof, but we're not mathematicians, so we don't really care. We're going to use integration by parts. Integration by parts. And remember integration by parts, it's the formula where you have an integral that looks like u dv, and you have 2 points, a to b. This equals uv from, let's say here, a to b minus integral a to b, then we have v du. Okay, so we need to assign a u and we need to assign a dv to our first line. So we're going to, down here, we're going to assign u. We're going to cleverly pick f of x, and so du dx is equal to f prime of x. Multiplying both sides, we can just get f prime of x dx as our du. And then for our dv is everything that we didn't use as our u, so that means we have delta prime x minus a dx. Now we have to integrate this. Okay, so we have v is the integral of dv, so we're just going to have delta x minus a. And now that we have all of these pieces, we just have to follow our integration by parts formula here. So the product u times v is going to be f of x, right? So this is our u. It corresponds to this u right there. We'll have f of x. Now we have v, which is delta x minus a. And we evaluate that at x equals minus infinity, x equals positive infinity. Now, since we're not evaluating this at the point x equals a, this term is going to be 0. So 0 because not at x equals a. Remember, the delta function is 0 everywhere away from x equals a. And so now we have the second piece of our integration by parts. We just have the integral from negative infinity to positive infinity. Now v is delta x minus a, and now our du is f prime of x dx, right? Well, now remember, we're just going to use the property of the delta function right here, right? So we know that if you have a function multiplying the delta function in an integral, we just evaluate that function at the point in question. So we have a minus sign out front, and the point we're going to be evaluating f prime at is at, well, none other than f prime of a, which is the line we wanted to prove above right here. So there you have it, folks. We have quote unquote proved this property of the delta function. So I hope you found this video helpful. I hope to be making more videos in the future, and as always, leave a like and a comment. Thank you for watching.